Before we begin this quick video on the angles formed by intersecting chords, let's take a quick look at what we've learned so far. We began with central angles. Angles formed by two radii with the center of the circle as its vertex. Now, therefore, we could imagine that we have an angle of x degrees formed by R2. You can see it hits the circle in those 2 points, creating an intercepted arc. And if that angle is x degrees, that intercepted arc will also be x degrees, because the ratio of a central angle to its intercepted arc is a 1-to-1 ratio. Well, then we moved on to inscribed angles. Angles formed by two chords with a vertex on the circle. And if we call the angle, the inscribed angle, to have x degrees, and we look at its intercepted arc, which we're highlighting right there, then we would say, well, that intercepted arc would be twice that, or 2x degrees, because we know that the ratio of an inscribed angle to its intercepted arc is a 1-to-2 ratio. All right, let's go on to our new lesson. 3. Angles formed within a circle by intersecting chords. Here we have given circle O, which means O is the center of the circle, with chords AB and CD drawn intersecting at point E. So let's go to the circle and find and make a chord. Let's start it right here and draw that chord across the circle, intentionally not going through the center of the circle. We don't want to create a central angle. Let's call that point A and that point B, chord AB. And it says that another chord will intersect that. So let's just draw a random chord. And the name of this chord is C, D. And it says that it intersects at point E. So let's put a little point E in there, like so. And now you could see that you have really, 4 angles that are created with intersecting chords, with 2 pairs of vertical angles that will be congruent to each other. And if you add up all 4 of those angles, it should always equal to 360 degrees. So let's just say that this angle right here is x degrees. That would mean that that angle on the other side of there is also x degrees, because vertical angles are congruent. Now, we're also going to notice that those 2 angles really create 2 different intercepted arcs, right? You have that angle that I marked as x will have dB as its intersecting arc, and its congruent vertical angle will have AC as its arc. And just to clarify here, let's actually draw in the names of those arcs, right? The arc right there is AC, arc AC. And the arc on the other side is arc BD. And you can see that they're different in their amount of degrees. So it turns out that the angle x will be the amount of degrees which is exactly in the middle of those 2 arcs. Well, how do we find the exact middle of 2 numbers? Well, I'm going to take arc AC and add it to arc BD and cut it in half. That's how you find the exact middle between any 2 things, right? You add them and divide them by 2. You're finding the average of those 2 numbers. And that will be exactly equal to that angle, whatever it might be. Now, in high school, you're often going to see this written in another way. Finding the exact middle between 2 numbers, sure, you could add them or divide by 2. But that would be the same exact thing, not to be confused with when you take two things here, arc A, or here AC. I accidentally put a little line there, but those should be arcs. 1/2 of arc AC plus arc BD would be the same as dividing them by 2. Now, some of you, I showed this page the other day at the very end, angles formed by two intersecting chords. Now we can see in this picture they have chords AB and CD as well, intersecting at point A, at E. So it's true that that angle, which is labeled at X degrees, is the same here. If you wanted to, you can also put an X there. You can see that the two intersecting arcs are 32 degrees and 54 degrees, right? If you look at that arc right there, that's 32. And if you take a look at this arc right here, that's 54. So quite simply, and you can see how that's written in the other way of 1/2 the sum. But if we just took those two arcs, 32 degrees, and add them together and divide by 2, that should be equal to our angle. Well, I'm going to work over here on the side here since I'm running out of room. So 32 plus 54 is 86. And I'm going to divide that by 2. And that should be equal to 43 degrees. So yeah, angle X is equal to 43 degrees. Now, you might also notice that once you have one of those angles, you automatically have two because they're vertical. And if you wanted to find the adjacent angle, they'll linear pair. So all you got to do is subtract it from 180, and you get 137. And that means that angle there would also be 137 degrees. Okay, let's take a look at 3 very basic types of questions with angles formed by intersecting chords. Let's look at first at question 26. In circle O below, chords AB and CD intersect at E. If the measure of arc AC is 30 degrees and the measure of arc DB is 50 degrees, what is the measure of angle 1? Well, they put a little 1 in there to make it simple. Well, I know some of you could probably do this quite easily in your head, but let's just mark up the circle anyhow. So arc AC is 30 degrees, arc BD is 50 degrees. So yes, quite simply here, all we need to do if we have the two arcs is add them up, 30 plus 50, and divide by 2, and that should be equal to our angle, which is 80 divided by 2, which is 40 degrees. Now, the question number 25 on the other side, everything we've done in algebra and of course in geometry, we also need to be able to work with general representations, right? Chords AB and CD intersect at E. If the measure of angle AEC is 4x, and the measure of arc AC is 120, and the measure of arc DB is 2x, what is the value of x? Well, I'm just going to structure this exactly the way I structured the previous question. I have the two arcs, so I'm just going to take that 120 degrees, the first arc, arc AC, and I'm going to add it to arc BD and divide it by 2. And whatever that is should be basically my angle that I'm looking for. Well, that is always true. So let's just substitute all of those numbers in. So arc AC is 120 degrees plus arc BD, which is 2x. I'm going to cut that in half and set it equal to the angle, which is here represented by 4x. Well, now I have an equation, fractional equation, And I'm going to use my algebra to solve for x. I'm going to put the 4x over 1, and I'm just going to cross multiply. 4x times 2 is 8x, and that's going to be equal to 120 plus 2x times 1, which is 120 plus 2x. And now I'm just going to carry the 2x to the other side. 8x minus 2x is equal to 120. 8x minus 2x is 6x is equal to 120. And x is equal to 20. And that really is all they were asking for here. But of course, we could go on and figure all the different parts out now. We could say that the measure of angle AEC is equal to 4x, so 4 times 20, which would be equal to 80 degrees. We can also say that the measure of arc DB is equal to 2x. So 2 times our x, which is 20, which would be equal to 40. And then we can go up there and say, well, okay, well, that 2x was actually 40 degrees. Our 4x is actually 80 degrees. And that should make sense to us because if you look at the two arcs, 120 and 40, 120 plus 40 is 160. And if you divide that by 2, it equals 80. 80 is exactly in the middle of 120 and 40. Finally, our very, very last question is really a backwards question, right? Everything we do forwards, we should be able to do backwards, like this question here. In the accompanying diagram of circle O, the measure of arc AB is 64 degrees, and the measure of angle AEB is equal to 52 degrees. And here they really want us to find the measure of arc CD. So since we don't have any x's in this problem, you could represent that arc with an x. And now we're just going to structure this problem exactly as the theorem states. If you take one of the arcs, x, and you add it to the other arc, 64, and cut it in half, dividing it by 2, it should be equal to the angle which we have given to us here, which is 52 degrees. Well, I'm just going to put that over 1 because I have another fractional equation, and cross multiply. Well, x plus 64 times 1 is going to be x plus 64, and 52 times 2 is going to be 104. And now I'm going to just drop down my x and bring my 64 to the other side and subtract. And of course, 104 minus 64 is equal to 40 degrees, which is right there, answer A. And there you have it, the 3 basic questions regarding intersecting chords and their angles inside the circle that are formed. So I hope you found this video useful. And we'll probably put another couple questions on Castle Learning just on these types of problems to check our understanding. And then we'll finally get on to the 4th. See you soon.